what is classical mathematics and how is it different from regular math? I'm Daniel with Polymath Classical Tutorials, and that's the question I'm going to try to answer for you in this video. So first, let me explain what I don't mean by the term classical mathematics. What I'm not referring to is what's also referred to by the term traditional mathematics. So classical math, traditional math, those two terms are more or less synonymous, and they're used to distinguish, well, traditional math from two or so other schools of mathematical thought which developed during the 20th century. But that's not what I'm talking about. What I'm talking about when I say classical mathematics is I'm using it as a kind of shorthand to mean math which is taught in a classical manner. And so when I ask the question, what is classical mathematics? This is really what I mean. I mean, how does one teach mathematics within a classical framework? Or perhaps, to put it another way, what is the most humane and the most enriching way to teach math? These are questions I've been asking myself for nearly a decade, and I want to share with you what I think is the best way forward and the best way to answer them. Now, all of this, or at least I should say, the reason I'm making this video is because I came across some folks online who were doing their best job to answer this question as well, which is, what is classical mathematics, or how do you teach math classically? And the answers they came to were not bad answers, I just think that they're inadequate, and I'll explain why. But the answers that they came to were basically, well, math is math, right? And so what you need to do to teach math within a classical framework is just to apply some kind of classical methodology to the material, which means teaching using some kind of Socratic method where you're asking good questions of your students to try to get them to engage better with the material. You're not just giving them the answers, but you're drawing the answers out of them through probing questions. I think that's a really good place to start. I just don't think that that's an adequate answer. And I don't think that it's as classical as we could be. So to really answer this question and to really come to an understanding of what it means to teach math classically, to have something which is a genuinely classical mathematics, we need to go back and look at history. Classical Christian education today has its roots in the early modern period, in particular in England. And so classical Christian education wouldn't exist without the English Renaissance. It's actually a direct descendant of educational theories largely developed in and around England between the years like 1450 or 1500 to 1650-ish. Those are ballpark figures. They're not exact, but you get the idea. And so during this period, you had lots of educational theorists, scholars, intellectuals wrestling with the question, how do we improve on medieval education? And these men were men like Ascham, Eliot, Houle, Coate, Erasmus, Juan Luis Vives, and I'm probably forgetting a few others. But there were a number of men who were disillusioned with medieval scholasticism. And by the way, the guys I mentioned were not the only ones. This was happening all over Europe, not just in England. But we're focusing on England because as English speakers, of course, what happened in England has had the most impact for us on our views of education. So what these guys were concerned about was in medieval scholasticism, there was what they felt was an unhealthy emphasis on logic and logical systems. Now, they weren't opposed to logic. It's just that they thought that the logical systems of the Middle Ages were too limited and had very little practical use outside of the universities. So they thought, well, this doesn't seem all that useful. Let's find things to teach so we can more adequately prepare students for, real life, something like that. Now, I'm not going to argue whether or not they were right or wrong to respond to medieval scholasticism in that way. I'll let you be the judge of that. But the fact of the matter is that was their attitude. And so their response then was, well, let's go back to classical learning, back to the classical world, into classical literature, and let's take our inspiration from there, because they believe that by looking back, that was the best way to actually progress forward, right? Forward progress has to be made in light of the best things of the past. So what did this mean practically for English education in the early modern period? Well, it means that we have to talk about rhetoric in a video on mathematics, because one of the things that all these guys really emphasized was rhetoric, because the social and political demands of living in the early modern period, just the reality of the age, meant that rhetoric was a really, really good tool. And so if you were an upper or upper middle class society, that was prioritized. And so in the grammar schools, there was a tremendous amount of emphasis on Latin oratory. In fact, the entire grammar school education was basically just an education in Latin. And so the way that they did this is very similar to how we still do it today. They had a standardized grammar, which was Lilly's grammar. It was standardized, I believe, by Henry VIII. And Lilly's grammar wasn't the official title, it's just what everybody called it. But they had reading and translation exercises from men like Tully and Cicero and Caesar, just like we do today. But the reason that they were focusing on Latin, right? Why are they doing Latin oratory and not English oratory? Well, it's because almost everything worth knowing at that time was written in Latin. And even a lot of Greek works, because you might be wondering, well, what about Greek? Isn't there stuff in Greek? Yeah, there is. But a lot of the Greek stuff had also been translated into Latin. So yes, there were lots of grammar schools where students were learning both Latin and Greek, but the emphasis was always placed heavier on Latin, because it was simply the more universal and more useful language. So here's the point I want to make by saying all of this, and this is my key point here. Latin was learned in order to make further learning possible. It was not learned for its own sake. It wasn't learned because it was good mental exercise. By the way, I'm not saying you shouldn't learn Latin because it's good mental exercise. I mean, the reasons we have today for learning Latin and teaching Latin are different than the ones they had. There's still good reasons. I'm not discounting that, okay? So those of you who teach Latin, I'm not trying to say we shouldn't be doing that. We should. We should definitely be teaching Latin, but for different reasons. Okay, so Latin was learned to make further learning possible, and that was really it. Well, that and aside from the fact that by studying the Latin orators, who were some of the most eloquent men, you would be able to then communicate very eloquently in Latin and also in English, because some of that would also some of those concepts and those skills would translate really well back into English, of course. Okay, so now let's talk about mathematics. The problem with the emphasis in rhetoric, which was built into the educational system of the period, meant that certain subjects, like mathematics, didn't get a lot of time or emphasis, unfortunately. And we see this, for instance, in books like Thomas Eliot's book, which strangely enough is titled The Book Named The Governor. It was published in 1531. He spends most of the time talking about, and let me back up and explain what the book's about. It's called The Book Named The Governor because it's a book basically talking about how to educate people who were to be governors and leaders, etc. That's why. And so in this book, pretty much all of it is focused on things that we would consider more to be literary disciplines. Things having to do with language. So basically the trivium, right? And there is some mention of the quadrivium, but it's limited to maybe one or two very small mentions. And so that suggests that, yes, the educated gentleman should at very least know something of the quadrivium, but that was never emphasized. Basically what he says is like, this is what people should know. Oh yeah, by the way, sure, the quadrivium, yes, has its place. Then he goes on to talk about other things which he thinks are more important. So yes, an educated gentleman should have some knowledge of arithmetic, some knowledge of geometry, some knowledge of music, which isn't to play music. It's actually harmonics, which is basically study of ratios, and astronomy. So those are the 4 mathematical disciplines in the quadrivium. Now, mathematics was de-emphasized essentially, not because it was not known to be useful, because it was, but insofar as it was useful, it was considered more the domain of people that were laborers or merchants, so not educated gentlemen, right? Because if you're an educated gentleman, you have people who can do, computations for you. It's not going to be part of your daily concern. And so, although there was some mathematical training, it really wasn't emphasized. This also means that in the universities of the time, there were almost no professors of mathematics. Most of the practicing mathematicians were functionally amateurs because they had to have other jobs teaching other subjects, or a lot of them were clergymen, because there was simply no space for them in the educational system to be able to continue their mathematical research. Okay, so this explains why, or I should say, these 2 things explain, right, which is the social prejudice against mathematics, as well as the emphasis on rhetoric in the educational system. Both of these explain why today educators have struggled so much to create programs of mathematics sharing in the spirit of the late Renaissance. And that's not to say that people haven't tried. There are lots of classical education groups and publishing houses that have created their own math curricula, but none of them really share in the spirit of the late Renaissance, despite the fact that they're doing their best. And it's not their fault. It's because no clear model exists. Our predecessors here didn't leave us any hints or helps on how to teach math in this kind of way, in a classical way, in a fundamentally humane and enriching way, the way that they left us models for other things, like literature and Latin, for instance. And by the way, I should also mention, just as a kind of aside, I'm not idealizing early modern education. A lot of it was really nasty. There were a lot of problems. And so the guys that I mentioned earlier, like Ascham, Hoole, Coates, etc., Erasmus too, were often reacting against what was actually going on in the schools. And so one of the things that's difficult to tease apart about this period is you have, on the one hand, the idealists, so these guys who I've been talking about, and then you have, on the other hand, what was actually going on in the schools. And what was actually going on in the schools was often at odds with the ideas of these scholars and intellectuals who were really trying to solve problems that they saw, current and past problems in the schools. So if it sounds like I'm idealizing early modern education, it's because I'm talking about what these guys thought should be the case. But it is true that there was a lot of stuff going on that was really not pleasant. For instance, beatings were common in schools. That was one of the things that pretty much, Ascham and Erasmus and others were really, really opposed to. But that's a subject for some other time. Okay, so let's think about how we can use Latin and literature to discover, by analogy, a genuinely classical system or a classical program of mathematics. All right, so how do we teach Latin? It's the same today as it was then, but we give grammar exercises, vocabulary exercises, we give translation drills. As soon as students are ready, we introduce them to Caesar and Cicero and others, but the key is that we introduce them to Latin authors. We're not introducing them to just random sentences, right, that we've just written in Latin to give them something to translate. No, we actually give them real stuff to translate that has some kind of real value. And how do we teach literature? Well, it's similar, but there are some things that make it a little bit easier. For instance, we usually take a great books approach to literature, which is to say we guide students through a selection of works in the Western canon. We have no need for translation exercises because we usually use works that are in English, right, or at least translations into English. So we don't have to worry about vocabulary and grammar drills and all that. But we still do need to teach certain concepts. So we have to teach students how to understand plots, how to look for things happening in character development. We have to teach them how motif works, symbolism, various poetic devices, all these things. And we teach these things both before and during students actually engaging with these works, right? So we teach these things before students read, Homer and Shakespeare. We teach this as they're reading Homer and Shakespeare. And the point, of course, is to enrich their reading, right? So that they actually understand what they're reading, so that they have they're able to get more out of it, so they can learn from these things, they can be enriched by them. Okay. So in other words, just to summarize here, both Latin and literature require foundations in the basics, right? But these basics are not ends in themselves. Latin doesn't stop at teaching drills. Literature doesn't stop at teaching, plot devices and symbolism and poetic devices. So these are tools, not ends in themselves. Okay, so the reason I'm making this point is because I want you to engage in a thought experiment with me, and now flip everything around, and let's pretend that we're going to teach Latin and literature the way that we teach modern mathematics. So if we were to teach Latin the way that we teach modern math, we would give drills in vocabulary and grammar. That seems pretty similar, right? We would give some translation drills, but the translation drills would be different. Rather than giving students broad passages from established works, we would give them maybe a handful of famous quotes from these works. And then we would give them an assortment of randomly constructed sentences that have no contextual connection to each other, aside from their structures, right? Literature. Okay, so if we were to do the same thing with literature, students would memorize, poetic devices, ways motifs are handled, plot structures, and then they would memorize summaries of the great works without actually ever reading them. So we wouldn't actually give students to read Shakespeare and Homer. We would just give them summaries to memorize. So the problem then, as I see it, with saying that to teach math classically just means to apply classical methodology to it, is that, and this is key, classical education always implies a particular kind of content. So one must not only ask questions to make students think, like with the Socratic method and whatnot, but one must also show students how to take the thinkers of the past as their teachers. And if you're not giving them access to these teachers of the past, then how are they going to do this? So, in practice, what does this look like? Well, it means that if you use textbooks to teach mathematics, the textbook should be understood to be there to provide a foundation for further learning. Just like Latin wasn't learned for its own sake, it was to provide a foundation for further learning, we should treat textbooks the same way. They're not the ends in themselves. They should be the beginning of the education, not the totality of it. So students should read the quote-unquote great books of math as early as is feasible for them to do so. So geometry students should read selections from Euclid's Elements. When I say selections, I mean like broad chunks, not just like a few propositions pulled out here and there, because that wouldn't make any sense. But broad chunks of Euclid's Elements. Book 1's a really good place to start. Algebra students should read selections from Diophantus, from Vieta, from Cardano, from Descartes. And the reason that it matters that we do this is that teaching math in this particular way has a potential to really deepen students' understanding and appreciation of mathematics in a way that teaching math in other ways simply doesn't. a strictly textbook approach doesn't do this in the same way. And so by reading mathematical discoveries in their contexts in which they were originally presented, that is to say, in these mathematical treatises, students will see that mathematics requires creativity, but they'll also understand and see the beauty that's in mathematics. Here's what I mean. It's really difficult to see the beauty in the Pythagorean theorem if your only experience with it has been as a tool to solve problems for homework, right? If you ask a ninth grader, is the Pythagorean theorem the most beautiful thing or what? They'll say, it's not. I mean, it's a thing I use, but it's not beautiful. It's just the equation. However, if on the other hand you show them what it means in the context of Euclid's Elements, right? Now there's a narrative. Now they have to go through 47 propositions, and the 48th, which is the Pythagorean theorem, now is understood to be the climax. And what you have is 47 propositions leading to this one glorious moment. Each proposition, this example of pristine and super clear logic, each building upon the other. And so now, when students encounter the Pythagorean theorem, in this particular context, it takes on a totally different meaning. And they can see through the beauty of the logic just how beautiful math can actually be. And that's totally different from simply being presented a formula and being taught to use it. Right? I mean, if you don't see the Pythagorean theorem, for instance, in this broader context of where it fits into the development of mathematical thought, then it's much more difficult to understand how the areas of two squares equaling the area of a third square has any kind of beauty in it. It just seems like a piece of trivia. So the way that mathematics is taught today, most students never have the opportunity really to wonder at mathematics, at the beauty of math, and they never feel the beauty of truth expressed in numbers. So this is why it's so important to put the classical back in mathematics. It's because it's not just enough to teach students to pursue goodness and truth. We have to show them that there's also beauty, and we have to show them how to pursue it.